Hello everybody. Okay, this video is basically a domain summary. Okay, so I'm going to try to encapsulate all the important domain stuff in a video that's under 15 minutes. So here we go. So let's remember the fundamental principle that division by zero Division by zero must be avoided. Check out the division by zero video if you're not sure why. And also, the square root of a number the number inside the square root must be greater than or equal to 0. Otherwise, the square root of a negative number is imaginary. And that is not real, okay? Imaginary is not real. So to keep things real, the number inside the square root has to be 0 or bigger than 0. And we must avoid division by zero at all costs. These are the two fundamental concepts behind the domain right now. There is a third reason that we're going to talk about way later in the year, but again, that's way later in the year. So let's go through a few examples. I'm going to start with a very simple example. First, something like 1 over x plus 4. Okay, so what we want to do is we want to think about any number, any possibility of any number that produces 0 in the bottom, okay? And there's a very easy way to do this. Just take whatever's in the bottom and literally set it not equal to 0, and then solve that equation. I'm going to subtract 4 from both sides, and I get x cannot equal negative 4, okay? So if I put negative 4 in here, I get negative 4 plus 4 is 0 on the bottom. We don't want that, okay? So this is the only number in the world that gives us division by 0. So our domain is going to be literally every other number. Negative infinity to negative 4, union with negative 4 to infinity. There we go. This is how we say every number in the world except negative 4. I'm not doing set builder notation because this is just about finding domain. This is not about using both notations. And as I said before, in calculus and pre-calculus, we prefer the interval notation whenever we can. So I'm just going to leave it just like this. Let's go through some more examples. Let's say my problem is now this. The square root of 13 minus 2x. Okay, so here's the square root thing, right? So the number inside the square root, whatever that is, that number has to be 0 or positive. So literally, once again, all we do is we take what's in there and set it greater than or equal to 0. So this is an inequality. I'm going to add 2x to both sides. And so we get 13 is greater than or equal to 2x. Divide both sides by 2, and we get that 13 halves, or 13 divided by 2, is greater than or equal to x. Another way of saying that is x is less than or equal to 13 over 2. Okay? And so less than or equal to, that means we're going to have a bracket, but it also means we're going to start from negative infinity. Less than or equal to, okay? So 13 over 2, which is, 6.5. You can write that as well if you want. And then here's the domain for this square root function. Okay, how long have we been going? Only 4 minutes. We're doing really good. I want to throw a harder one in here. Okay, I'm at the bottom. So let's say we have this one now. F of x equals 3x to the 10 over the square root of 25 minus x squared. Okay, so if this were just a square root, we would set it greater than or equal to 0, just like we did in the previous problem. However, this square root is in the denominator. Okay, so not only can it not be negative, but also because it's in the bottom, we can't let it be 0 either. So in this case, we're actually going to take the number inside the square root and set it greater than 0 without the equal sign. Okay, and this is a quadratic inequality. Everyone has seen at least one of these in class by now. And so step one for any quadratic inequality or harder inequality is to solve the equation first. Okay, so 25 minus x squared equals 0. You can factor or you can bring x squared to the other side. I'm going to factor. This is going to be 5 plus x times 5 minus x equals 0. This is multiplication. So the product will be 0 anytime one of these factors is 0. So 5 plus x equals 0, or 5 minus x equals 0. Sorry, everybody. Solving this, subtract 5 from both sides. X equals negative 5. Solving this one, add x to both sides. X equals 5. Okay, equation solved. Step 2, we're going to form intervals from our solution. Form intervals from the solution. And I like to use this as a visual guide. You don't have to, but I think it's helpful. Negative infinity here, positive infinity over here. Our solutions of interest are negative 5 and positive 5. So sorry, everybody. Wow. Okay. So here we can see our intervals very easily. So negative infinity to negative 5. And again, this one does not have equality. So this is going to be parentheses everywhere. Negative 5 to 5. And then 5 to infinity. Okay. And we just want to pick numbers inside these intervals and test them out. So I want to pick negative 6 here. If 0 is available, I'm picking 0 every time. And I want to pick positive 6. And again, I'm trying to see if I plug it in here, do I get something bigger than 0 or not? Let's try negative 6 first. If I plug negative 6 in here, I'm going to have 25 minus negative 6 squared, which is 25 minus, and then negative times a negative is going to be a positive 36. And of course, that's going to give me a negative number for sure. So this is not greater than or equal to 0. So this one does not come with us. If I pick 0 and plug it in, we can actually put 0 into the non-factored form and get 25 minus 0, which is certainly greater than 0. So this interval is going to check out. And then if I put 6 in, it doesn't take that long to realize that this is going to give me the same result as I did up here, as I had up here. So this one's not going to work. And we finally get our domain as negative 5 to 5 with parentheses, meaning negative 5 is not in there, 5 is not in there, but the numbers, like for example, negative 4.9999999, that's in there. And so is positive 4.9999999. Okay. So there we go. That's a pretty comprehensive little domain video, I think. I did pretty good. I think I'm going to call this video now. How long has it been? 9 minutes? It's under 10 minutes. What a win. Okay.